All of these recent developments with regards to the reality mesh, including different sorts of sensor data, making it more shareable, the cloud services seem to point to, I want to say, a broader long-term vision of what the mesh is, rather than just a simplified data set. I wonder if you could maybe speak to that a bit. Like, what sort of trajectory do you see the reality mesh being on right now, and where would you like it to be in the future?
Sean, the mesh becomes a mesh up, if you like, if I can invent the term, for the immersive environment to find existing information, the digital engineering models that our engineers create that have never been updated because they couldn't be found. Now when you can navigate immersively through a reality mesh, the as-operated condition of any infrastructure or industrial asset, you can find everything else intuitively and immersively that you otherwise wouldn't have looked for. So the other work of engineers and surveyors will become more valuable because it can be found and persisted and shared in a practical way. But sort of your suggestion is right, that I like to say the mesh has helped reality modeling in going mainstream and having the professionals in infrastructure and industrial project delivery and asset performance in going digital, because the mesh is the tractable form for going digital and for immersing everything else. But I showed a slide showing the scale of the reality mesh processing this year so far across the world, and to compare, there are developing countries where there's just as much activity in reality modeling as there is even in the United States, because there the surveying professions are at different levels of maturity, and there are cases in point where instead of traditional total station surveying and so forth, with some ground control points, and UAVs can produce sufficient engineering-ready 3D surveys that I'm looking forward next month in Helsinki at the meeting of the Federation of International Geospatial Surveyors. That maybe is in French and I didn't say it right quite. But we're going to be talking about standards for 3D surveying. And really it is interesting for us to consider that, because when the inputs to reality meshes have come from automated processing, from inputs from cameras and sensors that have their own signatures, then we can contribute to standards by having the reality meshes capture and express the provenance of what devices were used, and even it's possible for us to assess what the accuracy potential is across various parts of a reality mesh, and it's interesting to consider setting standards in an automated context now. And so I look forward to participating in that discussion. But the whole point is it's a global phenomenon now, and with this increases in fidelity, in accessibility, in scalability, in shareability that we're bringing this time around this year. I indicated that in our year in infrastructure, we have our Be Inspired competition in various categories of infrastructure. Last year, about a third of the finalists, determined by the juries, this is in November of 2016, credited reality modeling with improving their projects. I expect that to be the majority this year in Singapore, where we'll be gathering in October for the Year in Infrastructure 2017.
So this question sort of brings together a lot of the themes that we've been talking about so far, say mobile capture, reality modeling going mainstream. I mean, how do you see the development of various sorts of outside technologies, things coming from other industries or consumer technologies? I recall in your keynote you talked a bit about machine learning, maybe autonomous vehicles, things like this. I mean, how do you see those affecting the way the people we work with do their jobs?
Well, Sean, we say reality meshes, and why wouldn't I say reality models? The difference between a mesh and a model perhaps is the degree of classification and intelligence that's done post-processing, if you like. So our infrastructure assets are made of functional components. They're in the sample plant that I show. It's the pumps and the valves and the controllers and so forth. I think in the coming year we'll talk a lot about automated classification of the components within a reality mesh. And the mesh itself may not be the ultimate expression of intelligence. If we could know what the functional components are, if we could, by the way, from photography, seek their nameplate and their tag data and relate that to an organization's experience in terms of reliability and understanding of the failure modes and effects and so forth, that really is even more valuable, is connecting that data together. And to your suggestion, machine learning is going to be useful in this process of classifying what's in a reality mesh to make it more intelligent. The geolocation, geo-coordination, as we like to say, is a great advantage in doing that. Where there exist digital engineering models with software like our engineering applications, they're already geo-coordinated. They know where in X and Y and Z they are, and then they can populate with their associated intelligence the reality mesh, so it becomes a reality model. It acquires the intelligence of the digital engineering models that can be associated and geo-coordinated with it. And that, by the way, that classification need only be done once, because once the association is made, subsequent surveys will inherit the geo-coordination information. But machine learning is another great way of recognizing functional components in a reality mesh. The great advantage we have is that here again, we don't have to invent certain technologies that are in which there's a tsunami of investment on the consumer side. So something like facial recognition or recognition of automobiles, as you're suggesting. Right. The Microsofts, the Googles, the Apples are working very hard at their AI-based approaches, if you like, the machine learning for that. We work with Microsoft and the Azure stack, so we don't have to invent any of that. We can just apply those advancements in machine learning to the problem of classification from reality meshes. Right. And I think next year we'll have an awful lot of progress to report and show in going from the mesh, from the reality mesh to the reality model, where the reality model will understand the behaviors and reliability information, and next of all the Internet of Things connections, right. Of which we'll have in our projects with Siemens for their MindSphere IoT environment. We'll have some new announcements next month in regard to that. But it's applying the technologies of others, as you're suggesting. It's definitely our strategy at Bentley Systems. We don't want to write any code that we could instead apply that's been developed, for instance, in our case, by Microsoft. So imagine everything they're putting into recognizing things in videos. That's very applicable to the classification problem from reality meshes. So the use cases and benefits are going to continue to provide even a better return on the investment that the SPAR3D attendees are making in reality capture technologies. And we want to have software that works with all of those and across the hardware approaches and multispectral and hybrid and so forth. But the end for us is advancing infrastructure, improving project delivery and asset performance. The reality mesh, a great bridge from one to the other, from conceptioneering and constructioneering beyond design into inspectioneering and productioneering. Again, further opportunities for the engineers and surveyors putting it all together. So I look with great excitement toward next year in Anaheim in SPAR3D and AEC ST together.
Well, thank you. I guess that's about as good a place to stop as any. I really appreciate the time.
Thank you, Sean.
And I'll see you again soon, I'm sure.